Hi and welcome back. In the last session we covered integer data types. In this session we're going to cover floating point data types. So now we've got our data types project open again, and we're going to put our code in the viewDidLoad event. Now let's start with a very simple float. Float f is equal to 0. So we've declared a new variable, float f. We've assigned it the value 0. Now floating points can have both negative. We can assign a -1. We can assign decimals in this case. Couldn't do that with integers. And it will store that value. Now there's a couple other things we can do. We can assign it an exponent. So we can assign it 1.123456789 e to the power of 10 if we want. Now that's going to give us a value of about 11 million. Now, let's see what that looks like when we display it in the debug screen. Now, let's say f is equal to %, and let's try f. It's going to warn us if we get the wrong specifier. That's okay. Let's try running that. Now, what we have here is we've displayed it 1.1234568. We have 3456778. Okay, we've run into one problem here. Now this is a precision problem. Basically, with the floating point data type, we have a precision of 7 points of precision. So that means after the decimal point, we have about 7 points, in most cases, of precision before we run into any problems. Now we've got 8192 here at the end. And that's not garbage data. That's what happens when you convert from the binary data type to here. And so you have to watch for the precision. There is also another issue here. If we add a number to it, we're going to add 1 to our floating point number, and then we'll display it again. And we're going to find there's another little issue here. Because of the precision, we get an interesting result. If we compare these two numbers, they're exactly the same, but we just added 1 there. What's happened is we've had an underflow error. So basically, we lost a value. We're missing 1. We could add a million ones individually, one by one, and we'd never see the result. We could just keep doing that forever, and we would have the exact same result. So this is one of the possible problems that you can run into. Now, we've got another type of floating point, which is the double type. And we're going to declare another variable, d, and we're going to set it to a value of 0. Now, we can run into the exact same problem here, but we've got a greater precision with double. We've got about 15 points. And so we'll assign a value of d is equal to, let's try 1.123456789 1.234567890 e to the 20. Let's try that. And then we're going to display it to the screen. %d is equal to, now it's going to warn us if we have the wrong type here, so I'm just going to use an f anyways. That's good. So let's run it, see what happens. Okay, so we've got 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, so good. And up to 5, 6, 5, 1, 2, 0. So we're missing a few on the end here as well. And so basically we've got a lot higher precision, but we can still run into the exact same problems. Now, one thing to remember as well about floating points is they are not exact. As you can see, we've got a few precision points of error there. And we can also run into that if we're doing comparisons. It's a very bad idea to compare things to be equal to floating point values, because they can be off by 1 precision point, and you'll never compare them as being exactly the same. And so usually it's better just to do a greater than or less than. Okay. So there is still one more problem here. If we were to assign, we've got a pretty large value here, double. We can also do a long double, which is even bigger. However, let's use this double and say d is equal to 2.2 e to the, let's try 1,000. However, we've assigned it an f, and we see that we have an warning. Magnitude of floating point constant too large for type float. Okay, let's display this, see what happens when we actually do set the value to something too large. And so we're getting an overflow here as well. So it's not just in integers that you can get that overflow, but here it behaves a little differently. So let's run this, see what happens. It gives us a value of infinite. So it actually declares it as being an infinite value. So we've seen a couple possible errors. You can, if you're below the precision and you're adding numbers, it stays at the same number, so an underflow error. You could have an overflow error. You can reach the infinite number. Okay, so we've basically covered the floating point data types. The only ones that we're missing is the string. We'll cover that later with a deeper coverage of NS string. But next up is going to be operators. Thanks for watching.